Good evening, great scientists, junior engineers, doctors, architects, sophios, and professors in different areas of science. This afternoon, we want to examine 2024 West African School Certificate, West Africa Senior Secondary School Certificate Examination, Physics Practical Track question number 2, underlined. This is the diagram of the question. This is a rectangular prism ABCD. You are provided with rectangular prism, 4 optical pins, drawing board, drawing sheet of papers, and other necessary equipment. Place the rectangular prism on the drawing paper, fix on the drawing board. Trace the outline ABCD of the prism 2. Remove the prism. Mark a point O on the line AB such that AO is about 1/4 of AB. Draw a normal through point D. Also draw an incident ray to make an angle I 25 degrees. I 25 degrees with the normal at O. Fix 2 pins at P1 and P2 on the incident ray. 3. Replace the prism. Fix 2 other pins at P3 and P4 such that the pins appear to be in a straight line with the images of pins at P1 and P2 when filled through the block along DC. This is the model of the rectangular prism. This is side A, side B, side C, side D. So when you place this one on the paper, you are going to place the P1, P2 here, and you check the images of these 2 pins here with P3 and P4 here in order to align it in a straight line. Number 5, remove the prism. Join points P3 and P4 and produce it to meet DC at point I. Also draw a line to join OI 6 with O as the center and using a radius less than the length of OA. Draw a circle to cut the incident ray and the refracted ray at E and F. This is E, F, this is G and H. Measure and record D, which is EF, and L, which is GH. Repeat number 8. Repeat the procedure for 4 other values of I is equal to 35 degrees, 45 degrees, 55 degrees, and 65 degrees respectively. In each case, measure and record D and L. 9. Tabulate your readings. 10. Plot a graph of D on the vertical axis against L on the horizontal axis. 11. State 2 precautions taken to ensure accurate result. 12. Determine the slope of the graph. Number B1. State Snell's law. State Snell's of a swimming pool which appears to be 15 meters deep when viewed directly from above its surface. Refractive index of water is 4/3. Now, let's start. This is the plain sheet of paper. So we are going to attach it to the drawing board. After that, we are going to place the prism on top of the plain sheet of paper. Trace side A, B, C, D. A, B, C, D. Remove the prism, then draw a normal at distance of 1/4 of the length. The length is 10 centimeters, so I will measure 1/4. 1/4 is 2.5 at AB. Do the same thing as CD. Join them together and produce it to the top. Now, after that, use your protractor to draw an angle 25 degrees. Allow 0 to align with AB. 90 degrees will be on the normal. So use at this 90 degrees, this is 0, 10, 20. This will be 20 will be in between 20 and 20. So this is 25. So you now use ruler to join the point. That's the point. So you locate point P1 and P2. This is the arrow to show that it is incident ray. Then after that is angle of incident I. Then you place your pin you replace the prism. Place your pin at P1 and P2. Then after that, use P3 to cover the images of P1 and P2. This is the point. Then use P4 to cover the images of P1 and P2 and pin P3. That is the point. So then you now remove the prism and the 4 pins. Join P3 and P4 and produce it to CD. Then join O with I. Use the right angle triangle to draw the perpendicular here. Draw the angle of emergence. Then after that, use your compass to draw a circle of diameter 2 centimeters, which is less than 1/4. 1/4 is 1/4 of this 10 centimeter rectangular glass prism is 2.5. Then you can use a radius of 2.0. You measure it on your ruler. Then the tip of the compass you have to be here. So that is the radius of 2.0 centimeter. Then you use your your right angle triangle to draw the point at which the circle touch the incident ray. You connect it with the normal. Yeah, the point at which it join it here also. The point at which it join the refracted ray, you connect it to the normal here. So after that, this is our E. This is F. This is G. This is H. This is emergent ray, angle of emergent. This is incident ray. This is the angle of incident. This is the refracted ray. So we can now move to the second. The second one is 35 degrees. Like we did in the first one. Sit down. So you trace it, the rectangular prisms A, B, C, D. This is A, you remove the prism, A, B, C, D, then you locate 1/4 of the length of the prism, which is 2.5. The total length is 10 centimeter. 2.5 on top and below. 0.5, that is the normal. Connect it together, connect them together. Use your protractor to measure 35 degree. This is 0. You allow 0 to align with a side AB. The 90 degree will be the normal. So this will be 0, 10, 20, 30, 35 will be here. So you join it to point 0. Oh, this is P1, P2. This is the arrow to show that it is incident ray. Incident angle here is 35 degree. So this one will give us, after that, you replace the prism back. Place the pin P1 at P1 here, P2 here, then you now place, you use P3 to locate the images of P1 and P2 so that the P3 will cover the images of P1 and P2, and the images of P1 and P2 and P3 will be on the same line. The same thing, you use P4 to cover the images of P1 and P2 and P3. So after that, after locating that, you remove the pins and the prism and join P3 and P4 produce it to DC to join DC at I using a right angle triangle. Can produce it down. So this is P3, P4, this is E. We now join O to I. You use the same radius you used for the first one, that is 2 centimeters. That's 2 centimeters. Then you can produce this forward. now use right angle degree to join the point at which the circle touch the incident ray. Then you align it with the normal. So this is the point. This is the point. Then the point at which it join refractive ray touch the circle. You join it to the normal here. So this is our E. This is F. This is G. This is H. That's the second one. Then we want to look at angle 45 degree. You trace the rectangle ABCD. Sit down. ABCD. Label it. After that, draw the normal at 1/4 of the length. The length is 10 centimeter, and the 1/4 of that length is 2.5. Draw the normal. Then use your protractor to find the angle 45. Allow the 0 point here to align with AB. Then 90 degree to align with the normal. Use this one as 0, 10, 20, 30, 40, 45. So you now join it to the point 0. After that, locate P1, P2. This arrow shows that this is incident ray, this incident angle. We use the same radius of 2 centimeter to draw a circle using the point 0 with the point tip of the compass at 0. Now, you now replace the prism. Replace the prism. Put the P1 at P1 and the second pin at P2. You now use P3 to locate the images of P1 and P2 at side CD of the prism, so that P3 will cover the two images of P1 and P2, and you use P4, the fourth pin, to cover the images of the P1 and P2 and pin P3. So after that, you remove the 4 pins and the prism. You join P3 and P4 and you produce it to size CD. Use your right angle triangle, be perpendicular, to locate point of incident, point of emergent. This is the angle of emergent. This is P3. This is P4. This is the arrow to show that it's emerging here. Now the next thing, so use the back remove the paper and draw the last 2 at the back. Place the prism trace the side ABC of the prism. Remove the prism, label it ABCD. After that, you locate the normal at 1/4 of the length of the prism, which is 10 cm. 1/4 will be 2.5 cm. On top, along AB and along CD. Then you join them together and produce it to the top. So after that, you now use your protractor to measure angle 55 degrees. You allow your protractor 0 point to align with OA, line OA, and normal will be on 90. So you now start counting from 90 to the left. 10, 20, 30, 40, 50, 55 will be here. You now join it to the center O. This is P1, P2. This is the arrow to show that this is incident ray. Now, use your protractor to draw, your compass to draw a circle of radius 2 cm. You continue to measure it because this is a circle of radius 2 cm. So you now use your perpendicular, your right angle triangle to join the point at which the incident ray touch the circle to the normal. Now, before that, you replace the prism, put pin 1 and pin 2 at P1 and P2. Now use P3 to locate the images of P1 and P2 at the point where pin 3 cover to the left. So this one will give us So this is the point at which P3 cover align with one another. P4 will now cover the two images of P1 and P2 and pin 3 on this side. You now remove the pins and the prism. Use ruler to connect P3 and P4 and produce it to line CD. Use right angle triangle to locate the point of emergent. Produce it downward. This angle of emergent. This is P3. This is P4. This arrow so that the ray emerge here. Join point O to point I. So after that, you write this is E, F. Then use perpendicular to join the point at which the refracted ray touch the radius of the circumference of the circle. So this is R, this is G, H. The next one, the last but not the least, is a incident angle of 65 degrees. You trace the angle, the prism. Trace the prism side A, B, C, D. Label it A, B, C, D. Then you locate the normal 1/4 of the length of your prism. The length of this one is 10 centimeter. 1/4 will be 2.5 centimeter. You locate that one on top, on line AB and line CD. Then you join them together. Produce it up. Now use your protractor to locate 65 degrees. Line where AB will be on the zero, on this 0 point. Line 90 will be on angle 90 will be on normal. You now count from 90, 0, 10, 20, 30, 40, 50, 60. 65 will be here. You now join it to the point O. So after that, you locate P1, P2. Put the arrow there to show that it is incident angle. Incident ray is I. After that, you replace the prism. Put P1 pin at the first pin at P1, the second pin at P2, then you use P3 to locate the images of the first 2 pins. That is the point. That is the point. Then use P4 to cover the images of P1, P3, and P1, P2, and pin 3. This is the point. You now rise up. Remove all the pins and the prism. Connect P3 and P4 and produce it to line CD. After that, use right angle triangle to identify the point of emergence. Let it align with CD. Reduce it down. This is P3, P4, then you join O to I. Now use radius of 2 centimeters to draw a circle and make the point O. Put the tip of the compass at point O. Now join the point at which ray angle of incidence touch the circle to the normal. Then the same thing here, the point at which refracted ray touch the radius. So after that, you now record the values. Measure length of CD. Measure length EF. Draw the table. Sorry. So this is I, incident ray. This is D. This is L. Sign is in degree, centimeter. So this is 25, 35 degree, angle of incidence, 45 degree, 55 degree, 65 degree. So we now start the measurement of D and L. At 25 degree, our D is 0.7. Our L is 0.5. For incident angle of 35 degree, our D is 1.1. Our L is 0.8. At angle 45 degree, at 45 degree, our D is 1.3. Our L is 1.00. For angle of incidence of 55 degree, our D is 1.7. Our L is 1.1. For angle of incidence of 65 degree, our D is 2 centimeter. Our L is 1.2. 1.2. So we now transfer the values. We now transfer the values to the table. This is D, centimeter, L, centimeter. The values we got, these are the values we got here: 0.70, 0.50, 1.10, 0.80, 1.30, 1.10, 55, 1.70, 1.10 for angle 65, 2.00, 1.20. Now, move forward. Now, I want to show something. This is case 1. This is case 2. This paper, raise it up. We call it traces. All candidates that perform this experiment must submit this paper, because without this, if you don't submit this paper, you lose mark for traces, which is 2 marks. You lose another 2 marks under incident angle, 2.5 marks for D, 2.5 marks for L, and 1 mark for table. That is 10 marks if you don't submit these traces, as simple as it is. And individual students that perform this experiment must make sure that he did it individually, no group work. So for this one, for case 1, the student performed the experiment himself, and he wrote his name, Akinkunle Lawal. This is what is accepted. But in case 2, this is group work. A single student performed the experiment and he wrote the names of all the members of the group. In center where situations like this arise, only the person in number 1 will be awarded the mark, the 10 marks for these traces. Number 2 to 10, you get 0. You get 0 out of 2 here, 0 out of 2 here, 0 out of 2.5, 0 out of 2.5, 0 out of 1 for table. That is 10 marks. So group work is not allowed in this experiment. If you embark on group work, only the first person, unfortunately, if the person that performed the experiment put his name in between 2 to 10, that means he doesn't have he did not perform experiment that year. He will come back next year. So if you are the one that performed the experiment, make sure your name is on number 1. Now, after that, go back to the next thing. Now, we've tabulated our reading. Number 10 is to plot a graph of D on the vertical axis and L on the horizontal axis. horizontal axis. This is the horizontal axis.
Sir, it's not showing me.
You cannot see.
Alright.
Bring it to this side. The highest value here, the highest value on D, this is D axis, centimeter, L, centimeter. The highest value is 2.0 on D axis, the lowest 2.0. So it is better to use 10 small square to represent 0.2. So this is 0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2 on the vertical axis. On the horizontal axis, we use the same scale, 0.2 to represent 10 small square. This is 30.0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. Now, we want to start plotting. When this is equal to 0.7, this is 0.6, this is 0.8. 0.7 will be between 0.6 and 0.7. I mean 0.8. 1, 2, 3, 4, 5. That's 0.7. Again 0.5. 0.5 will be between 0.5 and 0.6. 1, 2, 3, 4, 5. We trace it up until when you get to here. That is the first point. The second point, when D is equal to 1.1, this is 1.1 here, 1, 2, 3, 4, 5, again 0.8. This is 0.8 here. You trace it up until when you get to 1.1, 1, 2, 3, 4, 5. That is the point. Then the next one is 1.3, this is 1.3, L is 1.1, 1.3 will be between 1.2 and 1.4, 1, 2, 3, 4, 5, against 1.1, 1.1 will be here, in between 1.0 and 1.2, 1, 2, 3, 4, 5, trace it up until when you get to 1.3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's the point. When L is equal to 1.7, when D is equal to 1.7, L is 1.1. 1.7, 1, 2, 3, 4, 5, against 1.1. This is 1.0. 1.3 against 1.1. I mean 1.0. 1, 2, 3, 4, 5. Then 1.7 against 1.1. 1, 2, 3, 4, 5. 1.1. 1, 2, 3, 4, 5. Trace it up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The last but not the least, when is equal to 2, L is equal to 1.2. 2, 1.2. Now, after that, we now join the point together. We're going to join the point together. So these are the points. So the line called 2 points and the remaining 3 are evenly distributed both top and below. So after that, we are going to calculate the slope. Before you can calculate the slope, we are going to draw a very large triangle. Very large right angle triangle. We can use this point. 1, 2, 3, 4, 5. We can use this point and this. This right angle triangle is big enough to get good mark. You indicate it here, right angle triangle. Then you now locate Y2, Y1, X2, X1. So we want to calculate the slope. Slope is equal to Y2 minus Y1 all over X2 minus X1, or Y2 is 1, 2, 3, 4, 5. That's 1.9. 1.9. Y1 is 0.2.
X1.
No, it's Y1. It's on the y-axis. Yeah. X2 is 1.2. X1 is 0.2. So this one will now give us 1.9 minus 0.2 is 1.7. 1.2 minus 0.2 is 1.0. So this one will give us 1.70. That's our slope. So after that, the next thing is precaution. In this experiment, whether students write precaution or not, the moment they have a neat traces, this paper we call it traces. If it is neat, without writing it, the examiner will check the paper. If it is neat, we get 1 mark under precaution. Then another precaution here is I avoided parallax error in reading protractor. I avoided parallax error in reading protractor. The second one, I noted and corrected zero error on protractor. In reading protractor. Then B1, in B1 you are directed to state Snell's law. Snell's law states that B1, Snell's law states that the ratio of sine of angle, the ratio of sine of angle of incident to that of angle of refraction is a constant for a given pair of media. There are two medium here. Here medium and glass prism. So there are 2 or 3 things that are very important here, that if you did not write it, you may not get the mark for the law. Pair of media, sine of angle of incident, sine of angle of refraction. Those 3 things are very important. Then B2, you are directed to calculate what is the real depth of a swimming pool, which appears to be 15 meters deep when viewed directly from above its surface. The refractive index of water is 4/3. So N is a refractive index. Formula is a real depth of our apparent depth. So our refractive index is 4/3. Read that. That's what we are looking for. Apparent depth is 15 meter. So this one will give us 4 times 15/3. That is 60/3. So real depth is 20 meter, telling us that in most cases when you go to the swimming pool, the depth which you see at the top is not the real depth, it's the apparent depth. The real depth will be greater than the apparent depth. You can see here, the apparent depth is 15 meter, but the real depth, when you calculated this, is 20 meter. So if you don't know how to swim, don't jump into the swimming pool. Thank you so much for watching this video. We are very grateful. I'm very grateful. Thank you.